Okay, similar triangles. We're not trying to prove similar triangles here. We're told that they are. Clearly this is the big triangle and this is the small triangle, and we just need to find out what this y is. And you can see that this one's 4 times bigger. So this is all a bit of BS, so we're going to use the BS principle. Technically here, because this y is part of the small triangle, we're going to use the reverse, it's the SB principle. Small on big. So, can you see that that side and that side correlate to each other? And that side and that side correlate to each other. So I need the ratio of the yellow and the ratio of the green to be the same. So here the green is small on big and the yellow is going to be y on 9. So the ratio of yellow on yellow is the same as green on green. And once we get that started, all we've got is this equation, and we're solving for y. We want to move this 9, so let's multiply both sides by 9. Y equals 9 on 4, which is 2 1/4 or 2.25. There we go, we just found y. An easy way to see that, can you see how that was pretty easy when those triangles were separate? So I've got a big triangle and a small triangle. If I wanted to, I could draw them. Big, whoa, small. Okay. From the big triangle, can you see that that's 8? On the small triangle, that's 4. That's on the big triangle, so that side is x. That's on the small triangle, so that's 2. Big, small. So here the x is definitely on the big triangle, so yeah, loving the BS principle. Big over small. Now that we've drawn those, we can say, well, those sides correlate to each other and those sides correlate to each other. So I want a ratio for yellow and a ratio for blue, and those ratios are going to be the same. So let's do the blue. So it's big on small, so the big blue is x, the small blue is 2, and then the big yellow is 8, and the small yellow is 4. Okay, once we've done that, all we've got is an equation, single step equation, solve for x. Let's get rid of that 2. The 2's cancel, and then we're left with 4. So what's x? What's x? It's 4. If you can draw them separately, they tend to be a little bit easier. For those of you who have done enough of that and you don't have time or the care to draw them, let's do this one without drawing separate triangles, but clearly you could. There's a small triangle, there's a big triangle, you just got to draw them. So I'm going to use the BS principle. Let's find F first. So that's from the big triangle, and that's the corresponding or correlating side on the small triangle. So I need a ratio for green. Okay. Let's get a different colour. That's from the big triangle, and That's the same side in the blue triangle. So, from the big triangle, that is the number 6. So let's just go back to here. We need this blue ratio. Okay, green, big over small. Blue, remember that red line is the big line and that is 6 long, and then the small triangle is 2. So once that's done our job, the BS is done, we need just to solve that one-step equation. We're going to multiply by 3. The 3's cancel, and F will be 9. F is 9. F is 9. Let's get rid of all of that. So in an exam, having... Wow, that doesn't want to go. There we go. Having erasable pencils and rubbers is probably pretty handy. We want to find this G. So let's go again with different colours. Yellow. There's my big and there's my small. Big on small. So my big line there is going to be 4 plus G on small, which is just 4. So that's my yellow ratio. And let's just stick with the same blue ratio as we had before, because that worked all right. And that blue ratio was that 6 over 2. So we're going to have, there is our one-step equation. I wish it was a one-step equation. It's not. Tricked you, it's a two-step equation. Oh my gosh, how are we going to do that? We want to get rid of that 4. So let's multiply both sides by 4. Those cancel, and that's going to be 12. Let's subtract 4. G equals 8. G equals 8. Okay. Job done. Oh my gosh. Most of you can switch off now. Let's get on to some B-level questions. Or hang around, because this is fun. This is a B-level question because commonly kids will think that those two angles are the same, but they're not. It's alternate. So those two are the same and those two are the same. So that's why this is a little bit harder. Okay, let's still go. BS. Okay, we've got big and small. 6 over 3, and then we've got big and small. So just solve that by multiplying by 1.5. They cancel. 6 on 3 cancels to 2. 2 1.5 is 3, so x is 3. Now I've got to find this y. Can you notice that y is on these smaller triangles, so we really want the S over B ratio, not the BS ratio. So, small over big. So that's going to be y on 8 equals small on big. And a single step equation. So the equations aren't the hard bit, are they? That goes to 2, so y is 4. Hey! Whew. What do we do first? let's find I. So can you see I've got a big side and a small side. So my BS is going to be big, which is 5, over small, which is 2. And for I, that's my big on small, which is 3. Once you get them, those equations are easy. Multiply by 3. So I is 15 on 2, 7.5. Okay, I, H. Let's use that same BS, 5 on 2. So now I've got, that is my big, H plus 2.5 on my small, 2.5. I'm going to multiply both sides by 2.5. So H plus, those decimals, 5 times 2.5 divided by 2. Oh. Calculator city. H is 3.75. So see that H, it is 3.75. What that tells us is that now we've got a big side. So we can use our calculator. I'll write it in red. That big side is that plus that plus that. Which is 9.25. Because we still haven't found K. So let's do that now. Big over small. K on 3 equals big, which is now 9.25 on 2.5. Multiply by 3. 11.1. And I've still got to find J, but with everything else done there, I'm out of room, and this video is way too long as it is. So you can just do that. Let me know how you go. This is a bit of a challenge. I'm going to be pretty quick here. This isn't. This is proving that they're similar. So let's just do one at a time. So, see that angle and that angle, they're the same angle because I've got 2 parallel lines and 1 crossing. They are corresponding angles. I can also say the same about that green because I've got 2 parallel lines and 1 crossing. They are corresponding angles. And you can see that that angle is in both triangles. So what we can say is that triangle and that triangle are similar because of A. I've got 2 parallel lines and 1 crossing, so that angle and that angle are the same. I've got 2 parallel sides and 1 crossing, so that angle and that angle are the same. And in the middle, vertically opposite angles are the same. So guess what we can say about those two triangles? They are similar because of angle, angle, angle. Can you see that they're parallel? And that's across. So that angle and that angle. Oh. I've got 2. That angle and that angle are the same. So we've got the same angles. Let me just clean that up. That's not going. Eee. It can just stay there. That angle and that angle are the same. We can use the same sort of process to find that they're the same and they're the same, therefore similar triangles. That has to be a right angle because that's a straight line and there are 180 degrees in a triangle. I don't know what that angle is, but that plus 90 must be my orange. Because I've got that same angle here and 90, that must be orange as well. So they have to be similar because of AAA. Same thing here, we've got isosceles triangles. Those two angles are the same, those two angles are the same, and because there's 180 degrees in a triangle, those two must be the same. So sort of round and round, you won't really have to prove any similarity triangles because they're a little bit complicated, but that's how it works, and that's why it's a B level question for you.